I actually don't know if there's a good way to arithmetize here. Maybe we could. The problem is the a plus b thing is kind of weird. So I don't know, but we can definitely do what we've been doing on any exponent question, which is use the exponent rules and just get it to look like this ax to the b form. So I always have kind of a little bit of an order that I go with here. I would say let's get rid of some of these radicals first. So we can kind of bring this down here. And I would say that that's 6. Then I'm going to parentheses 3 to the 5th, x to the 45th to the 1/5, right? Because that radical can become a, actually, you know what? Let's shortcut it. I know what we're doing here, right? Because if we have, the b root of x to the a, that is x to the a over b. And each of these things has an exponent on it. So let's just cut to the chase. This is 5 over 5, and this is 45 over 5, right? So that's nice and easy. Now I am going to put that in parentheses because then I'm going to multiply that by, and do the same thing here, 2 to the 8th over 8, right? Because now this 8 becomes the denominator, and this would be x to the 1/8, right? Because that doesn't have a visible exponent, but if we wanted to, there it is. There's a 1 there, so done. Now let's reduce those fractions. So 6, 5 over 5 is 1, so that's a 3. 45 divided by 5 is 9. 8 divided by 8 is 1, so that's just a 2. And then x to the 1/8. We'll just leave it like that. So there we go. Now we can multiply. So we can just multiply these numbers normally. That's nice. So that's 6 times 3 is 18. 18 times 2 is 36. But I'm filming this kind of late at night, so let's just make sure. Yes, 36. Then we got to do this part, right? And remember, GERMDAS here, right, helps us, right? Our order of operations, GERMDAS. If we are multiplying things with the same base, we add. We go 2 to the right, shift 2 to the right. And that means we add those exponents. So this is going to be weird. This is going to be 9 plus 1/8. Okay, so 9 plus 1/8. So 9 plus 1/8 is 72/8 plus 1/8. So that is 73/8. So what is the value of a plus b? Oh boy. So we got to do more fraction addition here, right? Because a is ax to the b. A is 36, so 73/8. And here's where we're going to let Desmos do it because I'm getting lazy. So 36 plus 73 over 8. And it's going to give me a decimal here. Now, the tricky thing about this decimal, and this is what's annoying, is you only have 5 places to enter positive numbers into the student-produced response. So this is actually going to use 6 places, 45.125. So if you're going to do that, I believe you can enter it as 45.13 or 45.12. You can either round or you can truncate, but you have to still use as many spaces as they give you. But let's see if we get this as a fraction. Yeah, that's what I do. 361 divided by 8. That uses 5 spaces as well. 361/8. Boom. And I don't have to worry about the rounding. I'm not stressing about it. It's nice. And notice, Desmos just let me convert that into a fraction really easily. So definitely recommend doing that. But yeah, this question, it looks crazy. It requires a confident knowledge of the exponent rules, but it's just methodically going through those. So if you have those memorized, these exponent questions actually become pretty easy because you can just be a robot. You don't need to understand things in a deep level. You're just like, okay, this is what I'm doing. This is how the exponents behave, right? If I'm multiplying the exponents, I add, or if I'm multiplying the bases, I add the exponents. If I'm dividing the bases, I subtract the exponents, right? Just remember the GERMDAS thing and you should be good. And it's just a hard question becomes much easier. If there's another way to do it, let me know. I think most other ways of doing it is just going to change the order of how you simplify the radicals, the fractions, the exponents, all that stuff. But notice what I did not do. I did not at any point do 3 to the 5th or 2 to the 8th. I did not bother making those numbers big because I just knew it wasn't going to happen. It was going to simplify in some way. So that's the danger with exponents. Numbers get big really fast and then we get lost. So try not to do that. Try to simplify things in ways that keeps it simple, right? That's why we call it simplifying. So hopefully that helps. Let me know if you have any questions, but this is a great kind of question to really make sure you're solidly in the 700s.